Hi students, today I am going to explain alternating current through a pure inductor. Every inductor can have its own inductance, self-inductance. Self-inductance is denoted by L. It is measured in Henrys. You know, Henry is the SI unit of inductance. Assume that I am taking a coil symbol is this. Coil or inductor, both are same. But coil of multiple turn is also called a inductor. When this inductor is connected to AC source, alternating EMF, when definitely current is produced, but whatever the current which is produced, definitely it changes its value from some value to, and it reaches to the peak value. The peak current will be there when, so in the EMF is changing, current also changes, you know it already. You know one relation, instantaneous electromotive force in alternating current is equal to peak value into sin omega t. This is already known for us. So when an alternating current source is connected to any circuit, its instantaneous value depends on the peak value by using this relation. You know, here E is nothing but, actually what you are using, you are producing, you are giving alternating current source. Then this is passing through inductor. When it is passing through inductor, electromotive force produced in the inductor at any instant of time, formula is what? L di by dt. It's already, you know that. Induced EMF is nothing but L di by dt. You may ask, why? Actually, electromotive force is given by this source. But how can you say that it is the induced electromotive force? But I am considering that at any instant of time, the electromotive force given by this source is equal to the induced EMF, but in opposite direction. So that's why I am writing E is equal to L di by dt. Induced EMF is nothing but L di by dt. So that's why in the place of instantaneous electromotive force in the pure inductor circuit, I am writing di by dt. This you write E naught sin omega t, you write as it is. Just you write this di as it is, and you write E naught as it is, sin omega t also you write as it is, and dt if you bring it becomes numerator, the L if you bring it becomes denominator. Now you know di you write, if you integrate this circuit, what happens? Di, if you integrate the circuit, the integration of di is equal to integration of E naught L sin omega t dt. Why I am integrating? But I am taking di by dt, small amount of current in a particular instant of time. But if you integrate, you will get total current. So current is equal to E naught by L is constant, because self-inductance of the coil is constant, maximum value of the electromotive force is also constant. The constants are coming outside. Then you are getting sin omega t dt. But after integration, you know, integration of sin omega t is what? Minus cos omega t divided by omega. I think you know this. Integration of sin omega t is what? In the place of this sin omega t, if you cancel this integration, you will get minus cos omega t by omega. It is pure integration. Now, E naught by L omega you write separately. And you write minus here, no problem. So cos omega t. Then E naught by L omega. Omega L means what? Omega L, I already said, omega L is nothing but inductance of the coil, the inductive reactance of the coil. This is denoted by XL. Inductive reactance means every, whether it is resistor or capacitor or inductor, all these components will oppose the current. The opposition offered by these components to the current is called resistance. But in case of resistor, it is called resistance. But Opposition offered by the inductor is called inductive reactance. This XL is nothing but inductive reactance. This inductive reactance is nothing but omega into L. Omega into L, angular frequency of the AC source and self-inductance. Then this is cos omega t, you write as it is. Now I am writing this step as it is, E naught by omega L. So just I am writing in the place of XL, again I am writing omega L. This can be written as cos omega t. Now you write E naught as it is, omega L you write as it is. But the minus cos theta can be written as sin of omega t minus pi by 2. That means the E naught by omega is nothing but I naught. Sin omega t minus pi by 2. Therefore, you can write instantaneous current at any instant of time in the circuit. Instantaneous current at any instant of time in the pure inductive circuit is I equal to I naught sin omega t minus pi by 2. But what is the relation of electromotive force? Here electromotive force is the cause, current is the effective. So electromotive force, instantaneous electromotive force at any instant of time is E naught sin omega t. But here E naught I naught. Sin omega t. So minus pi by 2 is extra. Pi by 2 means 90 degrees. Pi by 2 radians. That means what? Here current is behind the EMF by 90 degrees. Now I am going to explain phasor diagram. So if in the phasor diagram which is showing the electromotive force is making an angle omega t, then current is 90 degrees. You see current relation and electromotive force relation. Current is sin omega t minus pi by 2. That means the current is 90 degrees behind the electromotive force. At any instant of time you observe. So the current and electromotive force are 90 degrees out of phase. But current is behind the electromotive force. By using these two equations, you can immediately draw this phasor diagram. But how can you show the sine wave by using with the same? If this is the electromotive force E naught, this is minus E naught, then if you see this, current will be like this. This is I naught. What is the meaning of this? That means when the maximum value of the electromotive force is at t by 4 seconds or quarter of the time period, but the peak value is after 90 degrees, you are getting the peak value of the current. So in this way you can say this solid line is indicating the electromotive source, indicating the sine wave of electromotive force, but this dotted line is indicating the current. I hope you understood this.